Now the notation they used didn't have the vector symbols, but these variables are in bold in their print. So if you see a function that's in bold, that's going to be a vector. And if you didn't realize that, well, they give it in vector form, so that's like, wait, this is a vector? Oh yeah, it's in bold, because you can represent vectors with either a bold letter or with this arrow on top. All right, so they give us the instantaneous rate of changes of the horizontal and vertical component of our vector, so our vector prime. And they also tell us that at t is equal to 2, the horizontal and vertical components of our position for the vector is right there. Where is the position when t is equal to 6? So if we know where it is when t is 2, and you want to know where it is when t is equal to 6, we need to know how did it displace horizontally and vertically from 2 to 6. In other words, at t equals 2, we know where it is, and 4 seconds later, we want to know where it is. So what's the displacement from 2 to 6? The displacement is the rate times time, velocity times time. That's the total displacement from 2 to 6 horizontally, and that's the vertical displacement. So where it ends up is where it started plus its displacement in terms of a horizontal and vertical component. So 2e plus this, just use your calculator, but x prime of t, put in x raised to the square root of t. Just use your calculator for that and you will quickly get the correct answers. If you have any questions about the calculator use, I'll be at the entrance of the gym early. Come on by a little earlier and I can go over last minute questions if you have them.